For the emitter follower network, determine RE, ZI, Z0, AV and repeat parts B and D including R0 is equal to 25 kilo ohm. Okay, so for first 4 cases you are going to consider R0 is equal to infinite, which is given in the diagram. So you can see the diagram that it is an emitter follower network. So we have I have done a separate video on RE model of the emitter follower. So kindly go through it. So I'll write the formulas once again directly. So first part we have to find out the value for RE. So before going on to the formula, let me draw the RE model once again. So what you will do, first you will replace the transistor by means of its RE equivalent model. So you will be getting beta RE, and the output side you will be getting your current source beta into IB in parallel with that of your resistance, output resistance R0, right? R0. So this is going to be your base, and this is going to be your collector, and this is going to be your emitter. So it is an emitter follower network. So from the network you have your emitter resistor RE. Since it is an emitter follower, the output is taken across the emitter, right? So output is taken across the emitter, and across the input what do you have? You have your resistor RB, right? And your collector is grounded. So please watch the video for RE model. So looking towards your circuit, your overall input impedance is Zi, and from here let me take it as Zb. So Zb will be a combination of beta Re, since you have to make the current as common. So what you will be writing? So you will be getting beta plus 1 into Ib, right? IE in terms of Ib you have to write. From looking from outside towards your circuit, this will be your output impedance. Okay, so let me write the first value. Re will be equal to, you know the formula, which will be equal to 26 millivolt divided by IE. So what will be your Zi input impedance? Your second B part, Zi will be equal to RB parallel to ZB, right? Zi will be RB, capital RB parallel to ZB. So what will be your ZB? ZB will be equal to beta Re plus beta plus 1 into capital Re. So therefore I can write that Zi will be equal to RB parallel to beta Re plus beta plus 1 into Re, right? Now what will be your Z0? Z0 will be equal to capital Re parallel to small re, and your AV will be equal to capital Re divided by Re plus small re, right? So these are your, that is A part, B part, C part and D part. Now moving on to your E part, you have to repeat B through D. So you have to repeat your input impedance with the value for your R0. So input impedance will be equal to RB parallel to now ZB. In this case, including your R0, your ZB formula will be equal to beta RE plus beta plus 1 into RE divided by 1 plus Re divided by R0. Okay, so you will be having, you instead of ZB you have to find out this formula and you have to substitute. Okay, and now Z0, there is no change in Z0. For any value for R0, your Z0 value is Re parallel to small re, but your AV will be equal to, there is a change in AV. AV will be equal to beta plus 1 into Re divided by ZB divided by 1 plus Re divided by R0, right? So these are the formulas which you have to, beta plus 1 into RV, okay, which you have to apply. So moving on to the next part, we can start solving our problem. So let me go to the first part, that is finding out the value for Re. So Re, you know that what is the value? 26 millivolt divided by IE, right? So in order to find out the value for IE, you have to find out what is your IB. under DC bias condition, what will be your formula for IB? So VCC minus VBE divided by RB plus beta plus 1 into R capital E. What will be your VCC? In the given problem, it is equal to 12 volt minus VBE. You know that it is 0.7. What is your RB? Which is equal to 220 kilo ohm plus beta is equal to 100, right? So 100 plus 101 into 3.3 kilo ohm, right? So you will be getting, after solving, you will be getting somewhere nearer to 11.3 volt divided by 553.3 kilo ohm. So IB, you are getting it as 20.42 microampere. Okay, once you know your IB, you know that what is your IE? IE is equal to beta plus 1 into IB. Beta is equal to again 101 into IB is equal to 20.42 microampere. So IE, you will be getting it as 2.062 milliampere. Okay. So once you have got your value for IE, you have to find out what is your RE. RE is equal to 26 millivolt divided by IE. So RE is equal to 26 millivolt divided by IE is equal to 2.062 milliampere. Therefore, RE will be equal to 12.61 ohm. Okay. So you have found out the first value, which is equal to 12.61 ohm. Now B part, you have to find out what is your input impedance. So what is your input impedance? Input impedance is equal to capital RB parallel to ZB. So what is your ZB? ZB is equal to beta small re plus beta plus 1 into capital RE, right? So can we substitute the value? 100 into RE is equal to, what is the value? 12.61 ohm, right? Plus beta plus 1 is equal to, what is your value? 101 into capital RE is equal to 3.3 kilo ohm. So after calculating, you will be getting 1.261 kilo ohm plus 333.3 kilo ohm. So you will be getting ZB, which will be equal to 334.56 kilo ohm, which will be approximately equal to beta into capital RE. ZB, you have got the value. So once you have got the value for ZB, can you calculate what is your ZI? ZI will be equal to capital RB parallel to ZB. So what will be your capital RB value? RB is equal to 220 kilo ohm, and what is your ZB? ZB is equal to 334.56 kilo ohm. Okay. So now can we apply the formula? So ZI will be equal to 220 kilo ohm into 334.56 kilo ohm divided by 220 kilo ohm plus 334.56 kilo ohm. Okay. So you will be getting in and around 73603.2 into 10 raised to 6 divided by 554.56 into 10 raised to 3. So ZI will be equal to approximately equal to 132.72 kilo ohm. Okay. So the second value you have got it. Input impedance is equal to 132.72 kilo ohm. Now moving on to the C part, you have to find out what is your output impedance. Output impedance is equal to capital RE parallel to small re. So what will be your value? 3.3 kilo ohm parallel to small re is equal to 12.61 ohm, right? So you will be getting 3.3 kilo ohm into 61 ohm divided by 3.3 kilo ohm plus 12.61 ohm. Okay. So you will be getting Z naught is equal to 41.613 into 10 raised to 3 divided by 3312.61. So you will be getting Z naught will be approximately equal to 12.56 ohm, which will be approximately equal to Re, because what capital Re is equal to 3.3 kilo ohm and small r is equal to 12.6 ohm, right? So compared to Re, capital Re is having a higher value. So since it's a parallel combination, you can neglect the higher value. So your result will be approximately equal to your small value, which is proved. So Z naught is equal to 12.56 ohm. Okay. Now moving on to the D part. D part, you have to find out what is your voltage gain. Voltage gain is equal to V naught divided by Vi, which is equal to capital Re divided by capital Re plus small re. So you will be getting, what is your capital Re? 3.3 kilo ohm divided by 3.3 kilo ohm plus small r is equal to 12.61 ohm. So you will be getting AB will be equal to 3.3 kilo ohm divided by 3312.61. Therefore AB will be approximately equal to 0.996 will be, which will be equal to 1. So for the emitter follower, what is your gain? Which is equal to 1. So it is proving, right? It is proved. Now E part, you have to consider R naught is equal to, what's the value? 25 kilo ohm, right? R naught is equal to 25 kilo ohm and you have to repeat B through D. So first value is, you have to find out the input impedance. So input impedance, you know that again the formula is slightly modified. RB parallel to ZB. So ZB will be, now it's varying. So it will be equal to beta RE plus beta plus 1 into capital RE divided by 1 plus RE divided by R naught. Okay. So what is the value? You will be getting 100 into small re is equal to 12.61 ohm plus 100 plus 1. So you will be getting 101 into, what is your value for Re? 3.3 kilo ohm divided by 1 plus 3.3 kilo ohm divided by, what's the value for R naught? It is 25 kilo ohm. Okay. So ZB will be equal to, after solving, what you will be getting? 1.261 kilo ohm plus 294.43 kilo ohm. So ZB you will be getting approximately equal to 295.7 kilo ohm. Okay. So once you know the value for ZB, can you calculate what is your ZI? RB parallel to ZB. So ZI will be equal to RB. What is your value? 220 kilo ohm, right? 220 kilo ohm parallel to ZB is 295.7 kilo ohm. So apply the formula, 220K into 295.7K divided by 220K plus 295.7K. Okay. So after solving, you will be getting, I'm writing directly the answer, Zi will be equal to 126.14 kilo ohm. Okay. 126.14 kilo ohm. So Zi you have calculated. What is the next value? Z naught. You know that Z naught, there is no change for any value for R naught. So it is equal to Re parallel to small re, which will be equal to 12.56 ohm. There is no change. But whereas in the case of AV, you have a different formula. Okay, inclusion of R naught. So beta plus 1 into Re divided by ZB divided by 1 plus Re divided by R naught. So after solving, you will be getting AV is equal to, beta plus 1 is what? 101. 101 into capital Re is equal to 3.3 kilo ohm divided by, what is your ZB? 295.7 divided by 1 plus 3.3. I think you have calculated it, right? For the previous case. 1 point. So what will be a value? 1 plus 3.3 kilo ohm divided by 25 kilo ohm. The same value which you have calculated in the case of your ZB. Okay, same value will be reflecting. So you will be getting AV is equal to, somewhere you will be getting nearer to 1.1271 divided by 1.132. So AV will be approximately equal to 0.996, which will be approximately equal to 1. So these are the values which you have got with that is with the inclusion of R naught as 25 kilo ohm. Okay.